Alrighty guys, so we're going to be talking about logarithms today, and we're going to be talking about how they interchange from being exponential functions to logarithms. We got to be able to know how to do that. So the basic formula for that is log base b of y is equal to x if and only if b raised to the x power is equal to y. Now you're probably looking at that middle section going the I, F, F. That right there does stand for if and only if. So if you ever see that in mathematics, that's what they're trying to communicate. So looking at an example of this right here, say we were going to go ahead and do log base 2 of 16 is equal to 4. Say I want to convert that into an exponential function. The way I would write that is I'd say 2 to the 4th power is equal to 16. So the idea here is that these pieces, the 2 and the 4, go together and they equal the 16, okay? So once again, let's go ahead and try another example. Say I have, I don't know, log base e to the 1 is equal to 0. This is true if and only if we have e to the 0 is equal to 1. So once again, you have e and the 0 go together, and then this is equal to what's in green, the 1. So let's keep it going. Let's try another example. Let's do log base 12 of 12 is equal to 1, okay, if and only if 12 to the 1 power is equal to 12. Now that's, hopefully makes more sense. I mean, 12 to the 1 power is just 12, right? So hopefully that makes more sense. And so as you can see, those go together and then it's equal to the 12, okay? Alrighty. Now, let's go ahead and maybe try to think about it in the reverse order, because I know that might be a little intimidating at first. Okay, so we're going to rewrite exponential equations into logarithmic functions. Okay, so say I have 5 squared is equal to 25. Well, that's true if and only if the log base 5 of 25 is equal to 2. So the idea here and what just happened is the 5 and the 25, okay, go together, okay? So this went here and this one here. And then, of course, you've got your 2. Oh, that's not a highlighter. Here we go. There we go. The 2 goes right here, okay? So let's try that again. So we have ourselves 10 to the negative 1 is equal to 0.1, okay, if and only if log base 10, okay, of 0.1 or 0.1 is equal to negative 1. All right, so try this again. Keep it going. So we have 8 to the 3 halves is equal to 4 if and only if you have the log base 8 of 4 is equal to 3 halves, okay? And if you're still not feeling confident, I'll do just one more. Let's do 6 to the negative 3 power is equal to 1 over 216, okay? Now this is true if and only if you have the log base 6, okay, of 1 over 216 is equal to negative 3. So the idea here is that this 6 right here is the base right here. And we see that this component right here, the negative 3, ends up being the y value, right? Or not the y value, but the x value, right? And then the 1 over 216, that ends up being what is attached to the base, okay? And it goes like that every single time. So if you're wondering, Mr. Farmer, does this happen every single time? And the answer is yes. Now, when it comes to these types of logarithms and interchanging and exchanging, there are two unique ones that we see very commonly in, I guess, the world and in nature. We see the common logarithm, and the common logarithm, we know that to be log 10 or base 10 of x is equal to log of x. Now, what you're seeing right here is that for the most part, most people see the common log as this guy right over here, and I'm highlighting him. We typically write him as this. We typically don't write in the 10, but it's understood that there is a 10 there, so just be aware of that. Now, there's also the natural, I guess I'm writing in blue now, the natural log, okay? And the natural log is written as log e of x, and we rewrite that as ln of x. Some of you might be familiar with this only because you see it on the calculator, but yes, log base e of x is typically seen and written as this guy over here, the ln of x, typically, okay? So let's go ahead and kind of interact with those guys. Now, typically where we interact with them is when we go to simplify expressions. Now, we're not just going to be simplifying common logs and just natural logs. We're going to simplify other types of logs. But those are the ones that we see mostly in business, in a lot of compounding continuously problems. And so we just want to make sure that we understand the operation itself. So let's start with the definition. So if I were to go ahead and say g of f of x, okay, is equal to log base b, okay, of b to the x, that's going to be equal to x. Now you're probably looking at that going, whoa, what just happened here? What's happening is the log base b, okay, this section right here, is going to simplify this b right here, okay? And I know a lot of you like to say the C word, but yes, that's what's happening here. And then, of course, the x pops out as the last man standing. And let me go ahead, let me get my highlighter. Right there, okay? Now, you can also interpret this just the same if you were to say f of g of x is equal to b log base b of x is equal to x. Now, hopefully you're making this distinction, and hopefully you've come to realize that these are inverses of each other. Because remember, if you take a function and put it inside of another function and you get a result of x, that means they simplify each other. So what's interesting is log functions are the inverse of exponential functions. That's kind of cool. So that's why we need to understand how to simplify them, because this guy right here, this base, will simplify because it's the inverse of this, and it gives us the result of x over here. So these are inverses, okay? So if I were to interact with an actual problem and say I wanted to simplify an expression that says 10 log base 10 of 4, well, the 10s are going to simplify because they are inverses of each other, and you get 4. That's your answer. Let's do it again. So say I had log base 5, okay, of 5x. That's going to give me x, because the 5s are going to simplify out and the x is going to stay. Now, let's kind of up the ante ever so slightly, okay? So let's say, I don't know, we have let's stick with the 5, log base 5 of 25 of x. Well, looking at that right there, you're probably going, well, the 5 and the 25, those are clearly two different numbers, Mr. Farmer. And I'd go, yes, they are. But we should be okay with, remember when I said that 5 squared was equal to 25 in a previous video, and we were all kind of like, yeah, no, I agree with that. So if I were to replace 25 with 5 squared, Isn't that now a 5? And hopefully you guys are kind of going like, oh, wow, look at there. And then on top of that, if I were to use the rules of exponentials, then I could say that this x is going to go inside here. And that gives me log base 5 of 5 times 2 to the x. Look at that. See what I did there? And now I can apply the simplifying property. And these are inverses, so they simplify out, leaving me with 2x. How cool was that? I think my excitement showed there. That was kind of cool, right? Now, those are problems. You're going to see those types of problems, so be ready for those. Now, there's also going to be instances where the natural log is going to come into play, and make sure you're okay with this. If I have e to the ln of, like, say, 20, well, this is the natural log, right? Interacting with the exponential. Well, this right here, these will simplify and give you 20. Same thing goes to be said if you have the ln of e to the 20. These simplify and give you 20. Okay, so if it was like that, it would simplify to give you 20. Now, looking at another example, just so that way we're okay with it. Say I gave you 8 log base 8 of x. Okay, that would give you, of course, x, right? Because these go away. But say I did this right here. I don't know. Let's do log base 2 of 64 raised to the x. So what I would want you to do, pause the video right here. Think about how you could convert 64 into a 2 and then see what you'd have to raise that 2 to. What power would you have to do it to? So go ahead and pause that right now. Hopefully after you're done pausing it, you'll come to the realization that it's actually 2 to the 6th power. Okay? And then, of course, using the rule of exponents, we get to plop that guy in there, and we have log base 2 of 2 to the 6x. Well, the 2's will go away, leaving us with an official answer of 6x. That's it for this video, guys. Great job tuning in. The next video is going to be showing us how we find the inverses of these logarithms and possibly a couple more details. So tune in for that one. Other than that, good job, guys. See you on the next video.